Okay, so we were talking about structured programming. In that, you have to define different modules, and in that modules, you have to write your mm, codes for different functionalities. So, majorly, when you are dealing with bigger projects, complex projects, that time you are supposed to use modular programming. After this also, you'll be working with, maybe in next 2 3 weeks you will be working on bigger statements. So you have to divide it into different functions. So what do we mean by functions? Like I have told you, void main is one function, and inside that we write everything, and that is the main function for which compiler look for, and from there it starts executing everything. Okay, so likewise we also can define different functions. So we have worked on this problem statement, addition of two numbers and multiplication and all those things. So here suppose instead of writing all the statements one by one, one after another one, what I'll do, I'll write one function, addition. Okay, open curly bracket, write whatever you want to do inside this one. Here you can print uh, the value of c also. Okay, likewise everything you can do for it. So everything I have done inside this one. Now what I'll do, I'll have another function, multiplication. You can give any name to your function. Naming conventions, I have told you that your function name should not start with the naming convention for variable and function are same. Your name should not start with a number, nor special character. You can use only one special character, that is underscore. And you can have alphabets and combination of alphabets and numbers also. So that way you can give any name to your function, and then open the curly bracket again. You can print the value of c here. Okay, now this is how I have written my code. Now in the main function, what I'll do, I'll just write the name of that function. Okay, and here also I'll call the name of that function. So what we call it, function call. We have given a call to this one. Okay, now what compiler will do, after coming inside this function, it will rectify this thing, addition function, and then it will look for the definition of function, that addition. So here agar definition of function mein, if you have misspelled it like this, you have missing the n, then your compiler will not find the definition of that addition function, because the name you have written here is not matching with the one you are calling inside the main function. Okay, so that has to be taken care of. So inside this function, whatever you have written, it will execute, and after this closing bracket, it will go to the main function, and that to the next line which you have written after the call of this addition function. Now again it will look for this function, it will go inside the multiplication function, it will execute everything. After the closing bracket, it will come to the next line. Now the return 0 is written, it means end of the program, nothing is to be written, and it will come out of the execution. Okay, so now if you look at this main function, only two lines are written, but in your program there must be 10 to 20 lines you have written for the addition and multiplication of two variables. Okay, now this code is good to look at. Okay, and it is quite compact, and when you are having some problem in addition, we will just look into the addition module. This is also called as, this is one module. Okay, see this terminologies, module, function, procedure, subroutine, all are same, just that they are used in different aspects. So when you are dealing with bigger programs, we call it as module. Okay, modules again have different submodules and functionalities. Then when you're dealing with c or something like that, you use functions and procedures. And when you're dealing with assembly language, you use the term subroutine. And when you use c++ and java and python, you call them methods. Functions को ही हम बोलेंगे methods. So it is just the name is changing, the meaning is same. Okay, so this module is dealing with this thing. Whatever error you get in addition, you just look into this module only. You will not look for the code of the multiplication. Now you'll say that we have only 15 to 20 lines of code for addition and multiplication, so it is easier for us to determine whether there is a problem in addition or not. But then yes, you have to look for, suppose someone else is looking at your code, he or she has to find out where you have written the code for addition. Okay, now here just looking at the word addition, they'll easily guess where the addition is, definition of addition, I mean the logic of addition goes, and they look for this addition thing. So this is how it works in the software industry also. People keep on changing their projects, so they have to maintain it properly. Now not all are having good habits of writing codes in this way, in modular program, following the modular programming. So sometimes it might, they might find difficulty in finding the errors, and rectifying them, and then uh, finding their solutions also. So as a good programmer, you should always have practice of writing your code in a structured way, and we call it as modular programming. So understood why we are dealing with structured programming and why we are recommending it to you. It is nothing that you have to implement anything. It is just the way you write your program. Okay. It is something like you keep your clothes in your cupboard. You have different sections for t-shirts, shirts, jeans, dupatta, kurtis. So that is how you have to divide your code into different sections and make it look beautiful. So that is the only main intention, and other main intention is to rectify the errors and solve them, and provide the solutions quickly. Okay, any doubt so far? Have you understood what is structured programming?
Yes, ma'am.
Yes, ma'am.
Okay, great. Now we are going to, there are other slides also, you can just go through them, and I'll be sharing this PPT today with you all. So you can go through, we have discussed all of this structured programming, what all things are there in the structured programming and all. Okay, so these are some the one you are following right now is unstructured programming, because you're writing sentences one after another one. And Fortran and COBOL basics, and SQL scripts, database के लिए जो आप use करते हो, those are again unstructured languages जिसमें you do not follow any modular programming. But then Pascal, Ada, DBase, or Java, C++, these are modular programming. Even C++, you follow the modular programming. These are some differences. Okay. Now, when you write code, there is a process. So, Abhi, right now, I have just asked you to declare variables to accept input and to add them and then display their uh, value or display their result. But when you work on bigger projects, it does not happen like that. It is first they have to find out what all resources are required, what is the problem statement, is it feasible one or not. They find out different technologies, solutions, resources, hardware, software to support that one. Then they find out if that is feasible, if the client and the one who is giving them services are okay with all those requirements and things. Then the development team starts writing the code. Again, for the development team, there is a procedure to write code. They just not sit together and do that. And again, they have this thing, software engineering processes. They follow those processes, and accordingly, मतलब उसके लिए भी एक methodologies है, those you learn in the software engineering subject. So those methodologies they follow. उसका कुछ डिजाइन बनता है, उसके मॉड्यूल्स बनते हैं, and then after that everybody whoever working on that particular module, he or she looks after that module only, that team looks after that module only. Okay, so suppose there is some e-commerce team looking after e-commerce module, then database team, and then the purely front end team, GUI team जिसको हम UX UI design बोलते हैं. Then there is a testing team. So all such teams are there. They work on different modules. So when the requirement and analysis of your problem is done, the problem definition is nothing but uh, okay, so that I was telling you about for the bigger project. But then smaller projects also, you have this thing, program development life cycle. We what we say, not properly follow this process, but yes, once you are used to it, you do not write algorithms explicitly and draw flowchart for it. You directly go for coding. But then this is the thing that is followed for bigger projects. So problem definition is the one where you define your problem properly, whether to add two integers or two floating point numbers or what. Pura explanation you have to give. Then you have to analyze what all inputs are required, what are output are there, and any other requirements, hardware, software, that you have to mention here in the problem analysis, that you have to find out. Then you have to write down sequentially in English sentences what is going to be going to happen in your code. Okay, and that we call as algorithm. So whatever English sentences you write one after other is called as algorithm, and the sequence matters over there. Whatever sequence you are writing in that algorithm, that is going to be converted into any particular language. Suppose C hai, C++, Java, any language that developer is using. And then the output is cross checked. If you are not following the sequence, or if you are changing the sequence, your output will change. Okay, and then there is a pictorial representation of that algorithm, which is called as flowchart. And there are also pseudo codes, which are kind of algorithm, but we do not write what we say, long English sentences in pseudo code. And we write short English sentences, plus we use some syntaxes of um, what we say, C language or any language that is used. So it is a combination of algorithm and some programming language, and then we have this pseudo code. But it is more or the less like algorithm, just not having the long English sentences. And then after once you are done with this one, then you go for coding. And after that, there is a testing and debugging. Debugging is nothing but executing your program one line by line. I'll be showing you in the labs how lab turns, how debugging happens. Each line, you can see how each line is getting executed. How you also can see how the values of variables are changing, and how your compiler is, executing your code, how it is calculating addition, how it is printing it, all those things. And at the end, maintenance is nothing but, if there are any additions in your code or in your project, you can do that. If there in any functionalities that you want to remove, you can remove that. And that is how, once the software is launched, after 2 3 months, you find that there is a new version of that software is available. So that is how people work on. Also, websites are under maintenance sometimes, because they are changing the GUI of that website, or they're adding some new services in that website. Something like that happens, and that we call as maintenance. And the same thing happens again and again. Okay, so this cycle is repeated jab tak you're not satisfied. But for business purposes, this goes on, keep going on. Okay, so this is the life cycle of program development. So let's see the example of each step. This is your problem definition, addition of two number. Then there is a problem analysis, what is the input and what is the output. So here we require two numbers, which can be either integer or float, and output is addition of two number. And then we have algorithm. I have told you algorithm is nothing but writing English sentences in a proper sequence. So how? See, for two addition of two numbers, before we start writing algorithm, we have to write start and end. uh, that is compulsory. And the very first sentence should be start, Then second will be declare variables. Whatever variables you want, you have to declare them just like that. So whatever names you are going to use, you have to list down them here. It is not compulsory. You can avoid this and you can just write declare variables. After that, we read first number and save the variable value, variable in n1. Now this is again the optional sentence, save in the variable n1. You can just say read the first number comma n1, ऐसे भी लिख सकते हो. Or you can say accept the input for number first number comma n1. You can also say that. Then again you ask for second number. Then this is what we write, the our formula, sum is equal to n1 plus n2. The equation you have to write as it is, and then after that you print the value and then end of the program. These two are important because whoever is looking at your algorithm should know from where you are starting and at which point you are ending your algorithm. Okay, so these are compulsory. In between whatever sequence you have, that is to be written in a proper way. Okay, but these two statements will remain same, and it is not like that it will be of seven statements only. It will vary according to your code. Now right now here we require only seven statements, so it is of having only seven statements. Okay, are we clear how algorithms are working? Any doubts so far?
No, ma'am.
Now I want you all to go through this video. I forgot to tell you this yesterday. Go through this video quickly and then I'll give you one task. Done. Great.
Yes,
Yes,
ma'am.
So
ma'am.
great. So there you must have
Yes,
seen,
ma'am.
yeah, for loop, while loop के लिए how you are supposed to write the algorithm. I am not explaining that right now. We will be saying how to write algorithm for loop and do while and other control structures when we will be learning them in different units after this. So right now we are just focusing on the simple algorithms for which we are writing the simple programs. So I want you to write algorithm for the multiplication of two numbers. Write it quickly and tell me what difficulties you're finding while writing. Write an algorithm for the multiplication of two numbers. If you have not understood how algorithm can be written, please ask me. Then
Yes, ma'am.
great.
Yes.
So I wish you have changed only this thing over there. Multiplication is equal to n1 into n2, whatever variable name you have taken, right?
Yes,
Yes.
ma'am.
Okay. Now, when you declare variable, that time, whatever variable value, if you are writing it here in the algorithm, you should write the same variable names in your code also, and you should use them same variable names in your flowchart also. So everywhere, same variable name should be reflected. And when you are declaring the uh, hard coded values, so that time, what you have to write is this thing: declare variables and assign values to them, and likewise you have to write down the value. Okay, so this is how we write when we are accepting the hard coded value. Right now you're uh, are accepting the input from the user, that is why you're writing the statement read the value, or in normal English sentence you can write accept the value also. Okay, instead of read you can write accept the value also. Okay, so this is how it works. Now after this we have this flowchart which I was telling you that it is the pictorial representation of your algorithm. Or you can say, if you don't want to represent this algorithm, you can have a flowchart, and using flowchart you can uh, represent the sequence of your program, how it is working, or workflow of your program. Okay, so there are different symbols that are used in flowchart. So this is the oval shape which is used for start and end. As I have told you, there has to be start and there has to be end. Whoever is looking at your algorithm flow chart, they should come to know from where we have to start and where we have to end. Okay, so that is why it is required. Then these arrows are there to connect these symbols, all these symbols, and it is also showing you the flow of your uh, flow chart or your diagram, and also it represents the flow of your program also. Okay, so that is why these arrows are there. Then this is parallelogram. It is used for input and output. So in case right now you're accepting values from the user, so you can say accept value from user, and you can write that statement inside this parallelogram. And for output, print addition, print multiplication, that statement you can write inside this parallelogram. After that, there is a rectangle. This rectangle is there for any processes that you are working on, like you are writing sum is equal to n1 plus n2, multiplication is equal to n1 into n2, or any hard coded values you are using. That hard coded values also goes here, not here in the parallelogram. Hard coded values we also write in the um, rectangle, and you can write multiple sentences, like you are performing four operations here, so you can write all equations of all those four operations in a single rectangle also. It depends on you. Then there is a decision box, diamond box. In case you are using if else, then we use this diamond box. So if you are if you are checking if a is greater than b, then there will be two arrows, yes or no. Also people use true and false also, but mostly yes or no likhte hain, either capital Y and capital N, or properly yes, yes, and no, no. Okay. And if it is yes, then the remaining diagram you have to draw after that, after this arrow. And if it is no, then after that arrow you have to draw the remaining diagram what you want to do, if a is not greater than b. Okay. So that is why this decision box is there. Whatever condition you have, that condition you write inside this box, a greater than b and question mark, that thing you write inside this. So this is how flowchart works. So this is the flowchart of addition of two numbers, start and end, and inside that this we have the multiple symbols. So first we are accepting the numbers from user, so that is why it goes into the parallelogram. So here you can say accept numbers, input numbers, read numbers, any of these three words will do. Then after that we are performing addition on it, then we are printing the sum and ending it. Now here it might happen that this flowchart is bigger for some programs, and it is not fitting into one page. So there is another symbol called as connector, which is nothing but a circle, and inside that there is a alphabet that we write to give name to that connector. Okay. And we write it at the end here instead of end symbol. And on the next page we start with that connector again, we draw a circle with the same label that we have written inside that same alphabet, capital letter. And after that we continue with drawing the flow chart, and wherever we are ending, that time we write the end. Okay. So that is another symbol that was not there in the PPT. Actually these
Ma'am,
PPTs are, huh, yes,
which alphabet?
एनी अल्फाबेट यू कैन यूज, ए बी सी डी 27 है, उसमें से कोई भी एक यूज कर लो, एनी वर्ड लेटर यू कैन यूज,
Okay.
कैपिटल लेटर. So this way we draw a flow chart here. And in case you are not accepting input from user and you are using the hard coded values, you can draw here the rectangle, and you can say number 1 is equal to 100, number 2 is equal to 200, and after that sum is equal to number 1, number 2, and print. That's it. Now there is another way that you can do this for multiplication, addition, and all those things. If you have bigger list of variables which are accepting from user, you can list down them here by separating them with comma, instead of writing drawing different parallelograms for each one of them, because then your diagram will be bigger. So instead of that you can do it like this. So suppose you're accepting all the numbers at a time, and then you're doing addition, subtraction, all of them one by one. So you can write all the operations, equations of all the operations in the same rectangle. And in using single printf statement, if you are printing their results, then you can write print sum, comma, multiplication, all those things inside the same parallelogram. Now suppose this is one way that you are doing. So you will be having the same flow chart for that program of having four basic operations on two numbers. But suppose if you are doing it other way, that पहले दो नंबर एक्सेप्ट कर लिए, then addition किया, then printed its value. After that you are accepting another two numbers for multiplication. So after this print sum, what you'll do, again you will draw one parallelogram. You'll write input number 3 and number 4. After that you'll draw one rectangle. You'll say multiplication is equal to number 3 into number 4. After that you'll say print multiplication. So these three boxes will be repeated three more times for multiplication, subtraction and division. Are you getting me? This is another way. Are you getting me?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Because one problem statement has n number of solutions. So your way of writing program and someone else's writing way of writing program might be different, but you both are getting the same output. So your flowchart and algorithm might change. अ, मतलब एक हाथ दो लाइन ऊपर नीचे होगी, या स्टाइल ऑफ राइटिंग दी एक्सेप्टिंग दी वैल्यूज एंड performing the operation might be different, but you're getting the same output. Okay, so that is also possible, just that you get the same output. Now I want you all to draw flowchart for addition of these three natural numbers, first three natural numbers. Can you do that? And before that I want you to go with watch this video again, one more video in which I have mentioned about pseudocode also, and after that I will be showing you one pseudocode also. So go, it is just 3 minutes video. Go with watch that video and then draw flowchart for addition of first three natural numbers, and if possible write algorithm also. आपका practice हो जाएगा. Done. Done with the flow chart. We drawn flow chart for this problem statement. Write a program for finding sum of first three natural numbers. तीन तक ही ले लो. Are you finding any difficulty in that? Again for flowchart, for if else, for loop, do while loop, we have different way to draw it. That I'll be explaining you when we are when we learn this thing if else and for loop and do while. Because for that you should know how if else works, how for loop works, how do while works, and after that you could draw it using the flowchart symbol. Right now you know how to write sequential statements in a program and execute it. So that is why we are dealing with those symbols only. See, this is a kind of flow chart. Okay, okay, this is थोड़ा complicated होने की है. I'll explain it. इसको हम simplify करके लिखेंगे. You can take hard coded values also. Done? Any one of you? Can you show me your answer? Who is done? Yes. Or you're finding it difficult? You're not getting it? Is it like that? Are you able to draw flowchart?
Yes, ma'am.
Okay. What about others? You can write it in chat box also. Okay. Please one show us to do. Okay. Mm, I'm requesting you to join this whiteboard. Join that accept that invitation. Is it visible? Yeah. So
Yes, ma'am.
what we do first? First we will draw this oval shape. Here we will write this thing. We don't write this thing. We'll write here start. Okay. I'm just writing in this thing. Small. चलो, पूरा लिख ही देती हूँ. Start. ठीक है. After this, what we are supposed to do now? We don't know how to use if else and while loop. So what we can do? We'll take hard coded values. We will make it simple. Okay. So what we will do first? We have to say declare variables that you do not write. That is not compulsory. So what we will say? N1 is equal to 1, comma N2 is equal to 2 and N3 is equal to 3. N3 is equal to 3. ठीक है. ये थोड़ा इसके बाहर. Now after that, what we are supposed to do? Addition of them. ठीक है. Sum. Okay. Bear with my drawing. I'm using mouse. I have digital pad, but it was not getting connected. Sum is equal to N1 plus. Can you do that now? N1 plus N2 plus N3. Okay. And after this, print sum in parallelogram. You have to write print sum. Okay. Print sum. You can use any variable, huh? It is not like that कि sum ही लिखना है. And after that, end. Are you getting it now? Why
Yes,
we
ma'am.
made it hard coded values? Because there is a way to write it properly to accept those values from the user, but we haven't gone through those control structures. See, there they have said ki s is equal to +1, increment this value. If this is okay, then go back. All these things we don't know right now. See here, that is why I was telling you कि if else जब पढ़ेंगे, that time only I'll explain you this, because you should know where to put this arrow. Why this arrow is shown here only? Why not here? Why not here? For that you should know how if else works, and that time only you will be putting these arrows at particular positions. Okay. So this is the perfect way to draw code. Use when if you are asking the values from user, uh, or if not, then this way is also possible. But right now we are using the hard coded values, so this is perfect for us. This is simple one, and this is how we can have our flowchart for addition of first three natural numbers. Okay, is it clear now?
Yes, ma'am.
Okay, this is
Yes,
how.
ma'am.
Okay, fine. So this is how we are done with the first unit. There are some things, limitations on all those things that you can go through afterwards. I'll be sharing these. what we say PPT with you all. There are more assignments given in this PPT. You can um, practice them at home, and you can draw flowchart and pseudocode. I wanted to show you. Yeah, see, pseudocode is something in between algorithm and flowchart. It has this type of sequence, the sequence we are following in the algorithm, but it is also having the short sentences, but like we have in the program, but it is not exactly the program. Okay, see, if I is divisible by 3, or print this, or set this thing, all these are we are writing in algorithm also, but then on algorithm we are writing some bigger statements. Here we are having some short statements, plus it should look like a code, but not exactly a code. Okay, so when you apply for gate or something like that, some type of exams, that time they give you this type of pseudo codes, and they ask you to identify the output of the code, and if it is giving error or any other output, it will give you. So that time pseudo codes are used. Otherwise, for the flow of the program, you can have the algorithm and flowcharts. Okay, have you got the difference? What is pseudocode and what is flowchart and algorithm? So
Yeah.
these are more assignment problems here. Now, after this, we will be uh, uh, writing assignments in different ways. So first, we will have algorithm problem statement. Problem statement is nothing but your assignment statement, and then after that we will have this thing algorithm flow chart, which will be written by you on piece of paper, and after that you can have screenshot of your output and code in the same file, or you can copy paste output and code in the file, and that way you have to submit your assignment. Till now you were submitting it in the form of only code and output, because we were not done with the flowchart and algorithm, so I didn't ask you to do that. But the batches which are taken by Mengale sir, they might be doing it uh, this week also. But for my batches, I am exempting you from that. From next week's assignments, we will be following that format. Okay, I'll be sending you that format on the classroom. And now onwards, for my batches and for lectures, all lectures, we will be using the same link. I won't be sending you emails for the link. You have to go to the classroom and accept and use that link which is available in the classroom. I have made it visible to you all, so you can join that link and use that link for lecture and labs. For my batches, the same link will be used for all my batches. Okay, for Mengale sir's batches, he will be giving you a link. Okay, and if you have anything that you would like to suggest me for lectures and for labs, any suggestion, any feedback is there, please suggest me all those things, because I don't know whether I am up to the mark or not, or anything that I need to add during lectures or labs, that is also expected from you, because we are on the online mode. Otherwise, offline may we could easily identify what is to be added, or what all efforts can be taken to explain you all those things. So, because it is online mode, you have to come up with your suggestions and all those things. Don't hesitate. At least for FPL, you are free to talk to me and let me know what all things you want to uh, have in labs or this thing lectures. Okay, so this is kind of feedback that I'm asking you for. So just a second. Okay, so anything of that sort you can always tell me, because I am also the chairperson of this subject. I would convey my all these suggestions to other faculties also. Anything that you would like to tell me. Uh, Also, other batches, you, if you are not comfortable in your just a second.